Hi, I'm a futurist. I'm a professional futurist. I spend my time trying to look at where the world is going and in big, large, kind of systemic terms. More than that, politically, I'm kind of a liberal. And I've always been kind of on the progressive democratic side of the equation. And similar to, and consistent with that, I have for a long time been following the climate change kind of situation. And back 15 years ago, 10, 15 years ago, I used to spend a lot of time giving speeches in the Pentagon. And I'd have a room full of admirals and generals, and I'd show them these slides. I'd show them where global warming would have a chilling effect on the military. And I'd show them the slide that talks about losing control and how that if you kept going up this extraordinary kind of curve that we'd work our way toward runaway global warming. And if you looked at it in three-dimensional kind of terms, that you could see that, even if you met the Kyoto Accords, that the world was doomed, and what we needed was a survival pathway that would get us across the ridge of extraordinary kind of runaway global warming. And I showed him these pictures. I dug all of these out of my old slides. I showed him these pictures and these statements from scientists that said that the Himalayan glaciers were melting fast, and there were these predictions that said that the whole Himalayan glaciers were going to be gone by the year 2035, and that there were billions of people downstream in Pakistan and India that wouldn't be able to have any drinking water because the glaciers would all melt. And then I'd show them pictures like this because, of course, the sea level was going to increase when all of those glaciers melted. And I'd show them pictures of towns like Seattle here, where the water was so high that if you've ever been to Seattle, it'd just cover the whole industrial area on the west side of Seattle and a good bit of the downtown area as well. And then I'd show them these flow charts about all the extraordinary kind of things that were going to happen because of all of this climate change and this global warming. And you'd see all of these things where the climate change would increase, and you'd get amazing kind of impacts that would happen, and then you'd work your way down this chart and you'd get to failures, and of course, and then you'd have global conflicts and water scarcity and then regional security issues. And then the worst thing of it all, of course, you'd get down to where there would be a global government that would probably come in. That would be horrible, of course. And I really believed all of this stuff. I really did. And I believed it because the studies by the IPCC, the Intergovernmental Panel on Climate Change from the UN, were saying all of this stuff, that this is really what was going to happen. And I bought into all of that like any reasonable person would at that period of time. And here's the IPCC just recently, late last year, that came out and said that they have a high degree of confidence. It's extremely likely that humans are responsible for all of this climate change, this global warming. And then they show you slides like this, which would show you that the amount of ice on the Arctic was decreasing significantly under what it was projected to be by all of their models, and what it's been in the past. And then you'd go to places like the National Geographic, and they'd all get on this bandwagon, and they'd start to produce all of these big colored graphics talking about how much of the North America was going to be underwater when this sea level rise. And so there was this combination of all these converging things that were all going to come down and just kind of destroy the place, and it was all going to be because of what the effects of human activity were. And then some amazing thing happened about 18 months ago. The Meteorological Office in the United Kingdom came up with this report and showed definitively that the climate, the temperature, the terrestrial temperature on this planet has not increased 1/10 of a degree in the last 16 years. There has been no temperature change. There is no global warming. And and more than that, then you started to get things coming out that were showing that there's more ice in the Antarctic than there's ever been before. And by the way, just recently a report came out that said there's more ice in the Arctic than there's ever been before. And you lay on top of that then the kind of reporting that starts coming in that's saying that it's been a record cold in Boston that they've never seen before. And you start to have questions about what in the world is going on here, because what the scientific community is saying is really at odds with what you're looking at and what you see all around you. Well, I started to look into this stuff, and I started to ask those kinds of questions quite some time ago. And I was influenced by a number of really bright, thoughtful people who had systematically looked at all of what was going on here and had come to quite a different conclusion than what I had understood and what was generally understood here. One of them was Pierre Sprey. Pierre Sprey is an amazing mind and kind of had a number of careers, but he's most well known for having developed and designed and being part of the team that designed the A-10 aircraft and the F-16, which are the most capable Air Force airplanes, some people say, that have ever been designed. The thing that's interesting about an airplane designer is that you have to be a systems thinker, because all of the pieces have to work together, and you've got to look at all of them at the same time and not just one piece. And more than that, the thing about an engineer is that if you're wrong, people die. If you don't have all this stuff right, if you're not really objective about this thing, then the device that you've got, whether you're building a bridge or building an airplane, is that it collapses or it crashes, and people die. And so the engineers are held to a much higher kind of level of credibility than scientists are. If scientists are wrong, well, then they come around and change their mind. And frankly, often it doesn't affect their reputation or any number of other kind of things. And so there was Pierre Sprey, and then there was Bert Rutan. My friend Bert Rutan here is standing next to me in this picture. And for those of you who might be interested in aviation kind of things, Eric Lindbergh, the grandson of Charles Lindbergh, is next in line here, and then Bertrand Piccard, who flew the balloon all around, nonstop around the world for the first time. And Bert Rutan is an amazing kind of airplane designer. He is the best that there is in the world today, and has designed many, many breakthrough aircraft. And here's a picture of him with Richard Branson, who he is working with to build the first commercial space capability. You can go ride in one of their airplanes and rocket yourself into space if you've got enough, a couple $100,000 or whatever the number is. But Bert was thinking about this and looking at all of this, and sat down and spent a couple of years systematically going through all of the data and looking at the original data and trying to build the case for what really was going on. And he was kind enough to provide some slides here that I'll show you here in a moment. And then Greg Braden, my friend Greg Braden, who comes from really quite a different kind of perspective. He is a scientist, but he's out in the kind of leading edge, looking at how science is really changing in dramatically different kind of ways from the kind of the main line, and has written a whole host of books that very well received and are extraordinarily well researched about the essential nature of how things are changing right now. And he too has come to the conclusion that what's going on here is quite different from what the scientists or the mainline kind of scientists are telling us about climate change. And then finally there's this young lawyer turned researcher, kind of solar and terrestrial researcher named Ben Davidson, who's got a website called suspiciousobservers.org. The O in observers, by the way, is a 0, not an O, if you look it up. Ben Davidson's an extraordinary guy who every day puts on a 5-minute kind of review of everything that's going on in the sun and in the cosmos and on the earth, and kind of integrates it all together to give you an update. And he's also come to the conclusion in very kind of compelling terms that something's going on here that's quite different than what we're being told by most of the folks in the business. The way that you have to look at these kinds of things is that you have to look at them in a systemic kind of term. You can't take one little piece and look at it. What you have to do is look at the whole system. You have to look at the history that's associated with these issues. And if you look at the history associated with the climate on this planet, and you go back like 410,000 years, then the patterns become really quite obvious. That what you start to see is every 116,000 years, that there are clear kind of increases in temperature that then fall off and go for a time of cooling or glacial period, and then it gets warm again and then it cools off. And it's just as clear and predictable as can be. There's something larger going on here that drives the world's climate, the planet's climate. And it certainly was going on a long time before human beings showed up here. And it's not only to look at this in historical kind of terms, but what you have to look at it is in terms of relative kind of terms. Because, for instance, scientists say that what's causing the climate change, they're calling it climate change now rather than global warming, but they say that it's anthropogenic global warming, that humans are causing the warming. And but it's much more palatable to call it climate change, and so they call it climate change. But they say what's driving that is human activity that is putting mostly carbon dioxide into the air, and that the carbon dioxide are these greenhouse gases, and it's getting reflected back, and it's driving the temperature up. Well, I mean, if you back away and you look at that statement, and you say, well, how much carbon dioxide and how much of it is humans and so on, what you get is a chart like this that says that here are the so-called greenhouse gases. Here are the greenhouse gases that are supposedly causing all of this, quote, climate change. And of the greenhouse gases, which are only 2% of the atmosphere, by the way, of that 2%, only 3.62% of the greenhouse gases are carbon dioxide. And of that 3.2%, only 3.4% of the 3.2% is CO2 that's caused by human activity. So that the amount of carbon dioxide that humans are putting into the atmosphere is just minuscule compared to the amount that there is there anyway. It's interesting. It's equivalent to if you had 300 gallons of water, 6 50-gallon drums of water, right? And you had them in a room at a certain kind of temperature. And if you took 1 tablespoon of warm water, that's 360 eyedropper drops, and you took 1 drop per day and dropped it, you'd have to spread it around over the 6 different drums of 300 gallons. and you drop a part of it in each one each day, do you think that that would make a significant change to the underlying temperature of the tanks? Understanding, that, by the way, that there's all kinds of other things that are having influence on the tank, which we'll talk about here in a minute. Nah, it's just far-fetched. The influence of humans are of such a minuscule scale compared to the other larger things that are going on, that it's just really a long reach and a little bit of hubris from my point of view to presume that this was all being caused by humans. The other piece of this, of course, is that CO2 is what makes us all grow, and that's we're all carbon-based life forms, and carbon is what we're all about. And you can't be a farmer. I'm not much of a farmer, but a little bit of a farmer to not know that CO2 is what makes plants grow. And if you want to really make plants grow in a greenhouse or something, you pipe in more CO2, and it increases the growth rate of all of your plants. It's really a very, and that really is at odds with this whole attempt to call it some kind of a pollutant. CO2 is not a pollutant. CO2 is an integral part of this whole system, and it's really quite a positive part of the whole thing. And then you see this kind of stuff, is that you now have a growing kind of consensus in parts of science that says that there's global cooling might be starting to happen. Not global warming, but global cooling. Now an increasing number of scientists are swinging back to thinking of like the 1960s and the 1970s. The global cooling hypothesis may have been right after all, they say. Maybe the Earth is entering a mini ice age. Well, in the face of all of that, what you need to kind of ask the question, is this anthropomorphic? Is this from humans? Is that humans causing this, or is there something bigger? Is there some larger kind of dynamic that's in play here that is influencing what's going on the planet? Well, one way to look at that is this chart. If you look at this chart, you can see that when you look at the ice corings, and if you look at the top one, the Russian Vostok ice corings, and that reads from left to right, what you can see is that the average temperature for the last 8,000 years has been warmer than it is now. That we're not at all as warm as it's been over the last 8,000 years, because remember, we're sitting at the top of one of those plateaus where it's been a warm period, an interglacial period. And if you look at the bottom chart is Greenland ice cores, and that one reads from right to left. The present is over on the left-hand side. And if you look at the green line across the middle is the amount of CO2 that's been in the atmosphere. And as you can see, that it's been flat right up to the last moment. But there's been wild excursions and changes in temperature on the planet throughout that period of time. And 8,000 years ago, it was considerably more warmer than it is right now. And so there's no direct correlation with CO2 at all with the temperature change on the planet. And then if you look at this and broaden it out and look at much broader, what you can see is that we are at the end, as I said earlier, of this plateau of a time of warming that's really quite significantly different than the recent ice age, the mini ice age that preceded this. And by the way, it's been warmer for the last 12,000 years on the average than it is right now. We are not at the warmest time on this planet by a long shot. So to suggest that this is some kind of anomaly that's been driven by humans is really not accurate at all. And then if you go to this chart, which shows where the peaks are, the warming peaks over the last 400,000 years, what you can see is that we're at the coolest of the warming peaks of all of them, when you go back 400,000 years or 320,000 years or 250,000 years or 110,000 years or so, is that each one of those, it got far warmer than it is right now. So what we're living through right now is not an anomaly. It is not human caused. This is a common kind of pattern that has existed throughout the history of our planet and the climate on our planet. Now, this whole relationship between CO2 and temperature is really quite interesting, because the whole argument that humans are influencing and causing this temperature change all hangs on the notion that the increase in CO2 is driving the temperature change. That in fact the increase that there was in global temperature back in the 70s and 80s, or going into 1990, was all being driven by the increase in CO2. Remember the big hockey stick thing that shows that the temperature and the CO2 were increasing like crazy. Well, the fact of the matter is, if you look historically, if you look at all for the last 410,000 years, and you look at it with some kind of resolution, what you can see, look at here on this chart, at the red lines. The red lines are the temperature. And you can see that the temperature increases and then the CO2 follows after it. That happens back over 350,000 years ago. It's the same relationship at 200,000, 250,000 years ago. When you open it up, you can see that it's the same relationship about 100,000 years ago. That, in fact, that the CO2 changes after the temperature changes. Now, if you've taken the time to watch this far, and you're following me and you're interested in this subject, you're bright enough to know that if the temperature changes first and then the CO2 changes, the CO2 is not driving the temperature. It's the temperature that's driving the CO2. And what you find out is that, in fact, that the temperature in the CO2 lags the temperature by somewhere between 300 and 800 years. And you can see this in this blow up of this chart, where you can see that each, and this is just during the last 10,000 years, each of the major excursions and changes in temperature generate comparable kind of change in the CO2, but it comes later. And so it's not CO2 that's driving the change. It, in fact, is the temperature. Now look at this chart. This is interesting because if you want to, again, take a big picture about what's going on here, what you need to do is look at the little square in the lower left-hand corner, which is the present period. See, it goes up to the year 2000 there, and you can see that there's been this increase in CO2. Now, if you see this kind of trend, this slope of this increase in CO2 that goes over the 21st century, and you project this out into the future, it's important to look at a couple of things. First of all, you can see that the green dotted horizontal line, that's where crop yields increase 35%. And that's where pine tree growth doubles. And so there's a nice place up there where plants start to grow and get grow much better than they do right now. And then if you go up to the white line, the white horizontal line, that the 1/10 of 1% CO2, that's the average amount of CO2 that's in an average home. That's the amount of CO2 in the average home. So I mean, we live in that kind of space. It's all around where I'm sitting here right now. That's the amount of CO2. Significantly higher than it is right now. And if you run the present trend, and by the way, the present trend and increase in CO2 is significantly greater than it has been in the past. But if you go run the present trend out, it doesn't even approach the average amount of CO2 in a room, in a home, by the year 2300. And more than that, then if you look at if you consider where pricing is going in terms of oil and natural gas and coal, what you can easily project and suggest is that by about 2080 or so, something like that, that the costs of fossil fuels are going to be and extracting fossil fuels are going to become so expensive that they will necessarily decrease in use, and the amount of CO2 that comes off of the use of fossil fuels will decrease by itself, long before it even gets to the average of the amount of CO2 that's in a typical home. So, I mean, there's a relationship, there's a set of large kind of relationships here that are really quite important that are not talked about typically by the mainline scientists who are operating in this space. Scientists are coming to the conclusion that ground temperatures, terrestrial ground temperatures, are not being driven by humans, but they're being driven by the sun. Read this highlighted place here. It says it's found that from 1610 until about the first half of the 20th century, the variation of long-term average terrestrial ground temperature is chiefly due to the variations of solar activity. This by a couple of Dutch scientists who just published this last year. It's the sun that's driving this kind of change. If you look at this chart, you can see that if you consider the full output from the sun on this top chart, that if you look at the solar activity, which is the red line, and the Arctic air temperature, the measured Arctic air temperature from ice corings and such, that you see a direct correlation between the kind of solar activity and the temperature relationship on the ground. And it doesn't lag, it's just the same thing. And if you look at the bottom of this chart, you can see that even though you had an increase in CO2 from the industrialization and human activity, there's no correlation at all between that and the temperatures. Scientists are saying that, like Greg Kopp at the University of Colorado, even typical short-term variations of 0.1% in incident irradiation exceed all other energy sources, such as the combined radioactivity in the Earth's core combined. What he's saying is that the sun is so great, so huge in relative to the effect of humans, and even the amount of radiation that's generated internally from our own planet, that it far exceeds all of the other kind of sources combined by a great deal. And then furthermore, guys like Tony Phillips at NASA, solar physicist, says that the sun's output varies not by a minuscule 0.1%, but by a whopping factor of 10 or more. There's pretty significant kind of swings in the output over time. And this can strongly affect the chemistry and the thermal structure of the upper atmosphere. So in fact, it's the sun. Here's a slide from Greg Braden that shows that if you look at historically back to 40,000 years, all of these, from the left-hand side, all of these jagged lines, that's the solar output from 40,000 years ago until 10,000 years, until going forward with some projections associated with it. And then over on the right-hand side where those arrows come up, you can see a dark line. Well, that's the temperature on the planet, and what you can see is that the temperature correlates with the sun's activity. That in fact, there's a far more direct correlation there than anything else. But some scientists say, oh, look, it's increasing so fast right now, there must be some correlation to the CO2 and human activity. Well, not so. If you look at this chart, you can see that you have the same slope of the line back from 1860 to 1880. You have the same slope from 1910 to 1940, and it's the same from 1975 to 1998. And so you can't lay the 1800s and the early part of the last century on the amount of CO2 in the air. It's just no correlation at all. until you say to yourself, what in the world's going on? Because the IPCC comes out, as they did back in December, I believe it was, and they say, look, the headline here, climate change report, it's extremely likely that humans are responsible. And you say, what's going on? What's this about? How can they say that humans are responsible when there are all this other kind of stuff that says that there really aren't indications that humans are responsible? Well, the fact of the matter is that their models are all off. They're all basing their theories based upon about 7 or 8 computer models. And all of those computer models are loaded with the assumptions that they have about how the climate system works. And their assumptions are wrong. Their models are wrong. Like this headline says, the world's top scientists confess that global warming was just a quarter of what we thought. The computers got the effect of greenhouse gases all wrong. And as a matter of fact, if you look at their projections on these 3 charts, the blue lines are what their projections were that was going to happen. And if you look at the red lines, they're significantly lower on the top 2 charts from any of the projections that were generated by the computers. Whether it's ocean heat or the tropospheric temperatures or greenhouse warming, all of them, none of them correlate. And by the way, they can't go back from now, they go back 16 years and make their models explain why the planet has not increased in temperature at all. Their models are wrong. They can't make them work. And then what they're doing is they mess with the data. They're screwing with this stuff. They're not being honest. Take a look at this chart. Any statistician will tell you that you need a certain amount of data points before you get any statistical relevance, statistical significance. And so if you look at this on the top, you can see that if you look back 16,000 years on what's indicated A here on this chart, you can see that you can get statistical significance from that slope because you've got a long period of time and you got a lot of data points. And then if you look at the point B and the slope in point B over across where it flattens out and the temperature flattens out for the last 10,000 years, this is a stable warm period. You got a lot of data points, 10,000 years in which to establish kind of a trend. And then if you take this last little highlighted yellow part and take it down to the bottom and you open it up and expand it, and you look at the last 2,000 years, which is the Christian era, well, again, you can get a slope there and you can get a trend there because you got enough data. If you then look at the last 700 years, which was a little ice age cycle, again, as it shows here, D, you've got enough time and you've not got enough data to make it to argue that there was a trend there. But the last 100 years is what all of this science is supposedly built around. And the last 100 years is not even statistically significant. And let me show you how they do this. Let me show you how they manipulate this information. If you look at this chart, you can see historically this 400,000 year graph that we've shown before that shows the big peaks where it got warm and where we're in this warming period that's not as warm as it's been in the past. And you can see that we're way at the end here on the far right of the green line on this. Well, what the global warming guys do is they grab just this last little part of the curve and then they open it all up and expand it, and then they show that the temperature is increasing over the last 100 years, and they suggest that that's really significant and that there's something unusual going on and that humans are causing that. They're also messing around with the reporting. If you, for instance, take a look at this chart, and it goes from 1950 to 1998. Remember, everybody says that there's been this dramatic kind of increase in temperature between 1975 and 1998, and certainly humans are causing that, influencing that. Well, this bit of temperature increase that stopped, by the way, in 1998, if you look at the underlying reporting, what you see is something really quite interesting. There's a significant drop in the number of reporting stations back about 1990, and that's when all of the temperature increases. And so you've got to ask yourself, what in the world happened about 1990? Well, what happened in 1990, and soon after that, was that you had this dramatic kind of revolution in the Soviet Union. And when you had the revolution in the Soviet Union, what happened is when things all went up into the air, what they did is they quit reporting and reporting temperatures. And so the amount of reports that came out of the Soviet Union decreased precipitously during that period of time after 1990. And I mean, think about it. What's the average temperature in the Soviet Union and Russia? Well, it's cold, right? And if you pull all of those data points, those otherwise cold reporting points out of the system, it's going to necessarily get warmer. And the mainline scientists don't consider that, or if they do, they cover it up. But then you say, so what if you took, what are the most accurate measurements of what the temperature on this planet are? And the most accurate measurements come from satellites, and they measure not the terrestrial temperature, because that's all subject to all kinds of things, the vagaries associated with where the reporting station is. But what you do is you do satellites, and they do the tropospheric atmospheric measurements. And if you look at the atmospheric measurements for the last 29 years, with global ones in the northern hemisphere and the southern hemisphere, what you can see here clearly is there's been no global warming. That it's all flat, that it's essentially flat. There's no significant kind of change. And so and then there's another way where they mess with it. And this is it starts to really get blatant. Take a look at this chart here. On the left-hand side is what was in the IPCC report back in 1990. And as you can see here, they indicate there was a medieval warm period starting about at the year 1000, and then there was a little ice age back that peaked around the 1600s, and now it's gotten warm again. That's what they said in 1990. And then 11 years later, when they did their new report, when they got on this jag about humans influencing climate and the fact that this was an unusual period of time, look at this chart on the right. What they did is essentially erased all of the little ice age and the medieval warming period, and all that they emphasize is at the end, where it's going up for this last little period of time. I mean, it's just blatant how they're manipulating this and how they're playing with all of this kind of stuff. Take a look at this chart. Here you can see two charts between 1915 and 1945 and 1970 to the year 2000. The red line is the temperature. There's been a slight temperature increase, about 1.6 degrees per century, and in both cases, about 1.6 degrees per century. But the amount of CO2, the rate of CO2 increase between 1915 and 1945 is 2.7%. And it's 13.7% between 1970 and the year 2000, yet the temperature increase has been essentially the same. The rate of change is essentially the same. There is no correlation between humans and all of this. And then you get reports that say, well, May was the hottest day in 2010 was the hottest May on record. Well, if you look at this chart, what you can see is that it always gets warm in the summertime, of course. And sometimes May is a little warmer, or June is warmer, or something like that. But May, as you can see looking backward, it's been far, far warmer in the past. as the summertime comes along, than, relatively speaking, than it is right now. But they cherry pick these little pieces and try to make them suggest that there's much larger change and much deeper things that are underneath all of this. And then they do things like this. They say the study shows that there's unprecedented warmth in the Arctic. And when you look into this thing, and you see that they say that since radioactive carbon dating is only accurate to about 50,000 years, remember that, think about that. And the record shows that it was a glaciation stage before that. The indications are that Arctic temperatures have not been matched or exceeded for 120,000 years. I mean, they're only accurate to 50,000 years, and now they're saying that the last few years, the last decade or two, have not been matched or exceeded for 120,000 years. There's a discontinuity, a mismatch there. And part of the problem is because of the way that they measure these things. Take a look at this. They sample ice in the ice corings. All this information is gathered from ice corings, and it's so compacted and dense that you can't get individual years. They're not even discernible. And so the carbon dioxide data is normalized over a 200-year period. And then they average the mean of these 200 years over 4 other 200-year samples, so that gives them a single data point for a 1,000-year period. And so when you look down, the closest that you can make any sense is 1,000 years. And so they average about 5 of these warming periods for one data point. And so what you get is literally the best that you can make any sense is about 230 years or something like that. But yet, when you look at what scientists are doing, what they're saying is the Arctic has been warming since 1900. The most significant warming starts around the 1970s, and it's only in the past 20 years that the warming signal from that region has just been stunning, and we expect all the ice caps to eventually disappear, even if there's no additional warming. I mean, you just can't do that. You can't do that. You just cannot compare the last 20 years to the last 10,000 years or 100,000 years or anything like that. So you say, why in the world are they doing this? Why are they messing with the data? Why are they telling this kind of stuff? Well, it all goes back to the history of science. If you know anything about the history of science, what you know is that there's extraordinary kind of pressure on the scientific community to get on the bandwagon and support what the present kind of theology is. As a matter of fact, science is a whole lot like religion. And that is that if you don't agree with whatever the doctrine is, they'll try to run you out of the church, and they literally try to do that with scientists. This is a really significant kind of a problem, and history is just fraught with guys like Michael Servetus, who discovered pulmonary circulation back in the 1500s, and you may not know what happened to him, but John Calvin, who was one of the founders of the Presbyterian Church, had him burned at the stake in the middle of a town in Switzerland because what he was proposing ran against what they thought that the scriptures had to say at the time. And of course, Galileo, everybody knows about Galileo, and the assumption is that that it was the church that made him retract his whole notion of heliocentric world. The fact of the matter is, if you go look at his literal notes that he took about why he did that, he said he was concerned about the kind of pushback that he would get from the scientific community, and that was the principal reason why he recanted, is because he was certain to be excoriated by the scientific kind of community. And it just goes on and on. I mean, Alan Turing, who helped us win World War II with his cryptology, was literally castrated by the government because he was gay. and they found that abhorrent at the time. And John Mack, who was a Pulitzer Prize winning psychiatrist from Harvard University, was literally, they tried to run him out of Harvard and get rid of his job and kind of depreciate his whole reputation and everything, because he did a reasonable study of individuals who had claimed that they had been abducted by aliens or something like that. And he honestly tried to look at them and said, I don't know whether they've been abducted by aliens, but they're not crazy. They've had a real experience of one sort or another. But that was just too much for the mainline science. And it took a threat of a lawsuit finally to finally get his job back. Well, it just goes on and on. There's whole science is laced with these situations where those who break the mold and try to push the edges get threatened and attempted to be destroyed politically and professionally and economically by those within the community. As far as I'm concerned, science is always wrong. You just have to wait long enough, because they change their mind. I mean, that's what science is about. Science is about learning. And unless you think we know everything that there is to know right now, then we're going to learn something new in time, and then we're going to change our mind and say, well, it didn't quite operate the way we thought it operated back then, and we now think it operates this way. That's what science is about. So the notion that science really knows exactly what's going on right now is fairly absurd. It's the best guess that we've got. That's what it is. And so what that turns into is things like this, is that glaciologists like Kevin Hewitt comes from having an expedition to K2, one of the highest peaks in the world, and he says, he observed 5 advancing glaciers, and he says, the evidence I saw challenges the view that the upper Indus glaciers are disappearing quickly and will be gone in 30 years. He says there's no evidence at all to support that. Indeed, the rates of retreat have been less in the past 30 years than in the 60 years before that. He said their models are wrong. They got it horribly wrong. They were just too quick to jump to conclusions on too little data. Well, that's given them the benefit of the doubt, as a matter of fact. It's been fairly charitable, because what it turns out to be is that the IPCC officials had to come back and admit that their suggestion that by 2035 all the Himalayan glaciers would be gone was really wrong, that it really wasn't going to happen. And they kind of started off by saying, well, we made a mistake. And then, as you can see in this Time article, the press started to dig into this and say, how did this panel get this wrong? And what they found out ultimately was that this is not a mistake. It was not an accident. As you can see here, David Rose, the coordinating lead author of the 2007 IPCC, said that there was no solid data to support the report's claim that the Himalayan glaciers would dry up in 2035. He said, we thought that if we could highlight it, it would impact policymakers and politicians and encourage them to take some concrete action. In other words, he says, last night admitted that the scary figure was put purely for political pressure on world leaders. And you might say to yourself, well, is that unusual, or why would they do something like that? Well, the reason why is because there's huge amounts of money and prestige and influence associated with all of this, and the money is in research money. Here you can see that the United States put $7 billion a year just just a couple years ago in just researching climate change. So there's a lot of research budgets that are hanging on the consistency or the presumption that this all is accurate. But then you say, yeah, but there's a consensus. They keep saying that there's thousands of guys behind this, and there's a consensus. Well, take a look at this. That the claim that there's 2,500 IPCC scientists agree that humans are causing climate change. Well, they say there's 2,500, but that part of the study, the physical science space, there were only 600 reviewers in that group 1 in the physical science space, and only 308 of them offered comments or recommendations on the report. And by the way, only 32 of them commented on more than 3 chapters of that group. So only 5 scientists commented on the whole report. So the notion that 2,500 scientists all agree is just absurd at face value. But then they come back and they say, hundreds of scientists agree that greenhouse gas caused most of the global warming in the last 50 years. Well, if you unpack that, if you dig into that, what you find out is that hundreds are 200 that they say agree. But when you look at the chapter, only 62 scientists reviewed the chapter where this statement appeared. 37 of their comments were rejected by the IPCC editors because they didn't like their comments, and 55% of the reviewers had vested interest to support one position or another. And so there were only 7 impartial viewers that had no vested interest in the whole thing. So, I mean, there's just manipulation at a fundamental kind of level here in terms of the numbers, and it's all for political reasons, to support the reputations and support the funding streams before all of this. As you can see here, one of the Frederick Seitz, who was the former president of the National Academy of Sciences in the United States, said that this thing, that they extracted all these comments out of the report to ensure that it conformed to a policymaker's summary. They eliminated sections that said none of the studies cited above has shown clear evidence that we contribute observed climate change to the specific causes of increases in greenhouse gases. And they took out the comment that said no study to date has positively attributed all or part of the climate change to anthropogenic causes. That's what some of the scientists tried to put into this study, and they pulled them out. And Seitz said this was the most corrupted peer review process that he's ever seen. And so then the MIT student newspaper ran this article about, remember when they hacked into the emails of the climate scientists? And Phil Jones, who was the director of a piece of this thing, he had this emails in which one of his, another scientist who was trying to establish the validity of all of this, who was on the other side of the equation and thought that there was questions about it, had asked repeatedly for the data, the underlying data that was used, and it was gathered using government funds, and so it should be available. And he asked, Warwick Hughes asked for it, and Phil Jones said, why should I make the data available to you when your aim is to try to find something wrong with it? Well, that's the essential process of science, supposedly, that you try to duplicate the science to try to find out if there's something wrong with it. But they wouldn't allow that to happen because what they knew is that if somebody looked into it, they were going to find something wrong and that they were going to upset their breadbasket. And if you think that this is unusual and this position is unusual, just take a look at all of these guys. These are well-known people, like Tim Wirth, the former Colorado senator, who says, we've got to ride the global warming issue. Even if the theory of global warming is wrong, we'll be doing the right thing. And you know, guys like Al Gore says, nobody's interested in solutions if they don't think there's a problem. I believe it's appropriate to have an over-representation of the factual presentations on how dangerous global warming is. That is to say, we'll lie about it, as a predicate for opening the audience to listen to what the solutions are. You know, all these guys, Paul Ehrlich, others, are all on the same point of view, and what they're saying is it's okay to overstate this, or it's okay to overinflate it, or even lie about it, because the ends justify the means. It doesn't make sense. And it even goes as far as more recently, where the German organization that was part of the IPCC, was really quite open about it all. And because, despite resistance from many other researchers, the ministries insist that it's important not to detract from the effectiveness of climate change warnings. And what this guy Ott, who is the leader in the Germans, said would result in the loss of support necessary for pursuing rigorous climate policies. What he said was, quote, "Climate policy needs to have an element of fear," he openly admits. "Otherwise, no politician would take on the topic." Well, you say, well, what about the rest of the science? Are there anybody on the other side? Well, the fact of the matter is that there's tens of thousands of them. And in fact, there's a petition that has been signed by 31,000 American scientists. And what it says is that there is no convincing scientific evidence that human release of carbon dioxide, methane, or other greenhouse gases is causing or will in the foreseeable future cause catastrophic heating of the Earth's atmosphere and disruption of the Earth's climate. Moreover, there is substantial scientific evidence that increases in atmospheric carbon dioxide may produce beneficial effects on the natural plant and animal environments of the Earth. I mean, it's really quite a different thing than what's going on and what's being generated by the UN and the IPCC. There's an alternative point of view about what's going on here. Part of the problem is that there are extraordinary kind of efforts that are being put into trying to modify the climate and modify the weather because of this underlying kind of notion. Science, because mainline science is making this argument that says that humans are causing this and somehow humans need to solve the problem.
Solar radiation management is the name given to their efforts to stop planetary warming. You've seen those days when the airplane trails don't disappear but grid and blanket the sky. The spraying of aerosols is supposed to be a last resort, not supposed to be in full operation over our heads. Patents even describe spraying out of airplanes. There are other aspects of weather modification involving wave propagation and air ionization, all types, high frequency, low frequency, on land, ships, planes, even satellites. More than I can name. Many believe you can see their signatures on radar and in the clouds. And when it comes to that radar equipment, there are those who believe their use of these frequencies is not just and more than what they're telling us, which would indeed be scary considering they're everywhere across the United States and the globe.
But that's not the end of this whole story. You know, the question is, if humans are not causing this, what's going on? What in fact is driving it? Well, the fact of the matter is something is changing, and it really is changing, and it's changing fast. And if you try to dig down and try to find out what it is that is causing this change, that something that's driving these cycles are charged particles and magnetic fields. That's what's causing all of these big changes. And these charged particles, magnetic fields, come from a variety of kind of places. They come from out of the center of the galaxy. Our Milky Way has got a huge X-rays that are coming out of that. There's a huge monster black hole that's 2.6 million times the mass of our sun that is spewing amazing amount of energy. There's also quasars and pulsars, which are sending extraordinary kind of beams of energy that come and hit our planet and hit our sun and hit our solar system. Furthermore, what there are these changes in the sun, as we've mentioned before, that the whole kind of operation of the sun is changing differently than it has in the past. And it's following a cycle, and a regular cycle. And the sun's powered at a new low. Right now, we're sitting here in the early 2014 at a solar maximum that is far, far lower than anything it's been in about 100 years. And there are not nearly the kind of activity that has been seen in the past. And there's a direct correlation to this, to things that happen on our planet, because, as I suggested earlier, the influence of the sun is so huge compared to anything else, and in fact drives all of the systems and all of the life on this planet. If you listen to things like Ben Davidson on Suspicious Observers, and what he says, he has brought this together and suggests that there are 4 different contributing factors here, things that happen. Is that the sun weakens the magnetic and the umbral fields. That what's happening is that the sun itself is going through internal kind of changes, and there's a collapse and a change in the magnetic fields on the sun, and that also change. There are a decreasing kind of magnetic fields on the Earth. And what that allows is more cosmic energy to come out of the sun, and more solar energy comes out, and it hits all of the planets, and it changes all of the planets. And so you say to yourself, well, if this is changing on the sun, then it shouldn't just affect just the Earth, but it should be affecting other planets as well. Well, in fact, that's the case. What you're getting is sunspots and changes in the sunspot activity, and the sunspots, which typically often produce these solar flares, explosive solar flares, and it produces solar mass ejections like this. And all of those things operate in a cycle, a sunspot cycle. And what we're seeing here, we're at the peak, we're at the solar maximum right now. And it is much, much lower than anything anybody has seen for a long time. And this change in energy is affecting all of the other planets in our solar system. Jupiter is seeing this huge kind of change in the big spot on Jupiter. And as Ben Davidson says, it's just happening in every planet.
We already know the sun is breaking stride. It's not just him and Earth. Venus' rotation is measurably slowing. The rates might seem trivial to us, but on a planetary scale, it's actually quite significant. Modern Mars quakes. The moonquakes version of this article has gone missing as well, but there's evidence of recent huge seismic activity. Jupiter is the most changing of the planets, a new red spot as the prominent planet-wide stripe fades considerably. After 50 years of monitoring Radio Jupiter, a new song emanates from Zeus, and a true electromagnetic event, the 2012 Jupiter flash, was blamed on asteroid impact, but there is no debris from an explosion and no cloud hole from an intact impactor. It's the concentric circles that give it away. The Saturn storm was only recently confirmed to be an anomaly. Saturn storms like this are regular occurrences every 30 years or so, but this was a decade early and has become the Energizer Bunny of Saturn storms. In 2004, they brushed off Saturn's slowing rotation as their error. Perhaps not. And for as long as Hubble has been out there, it was just recently able to see the auroras of Uranus. You can faintly see its little rings as well.
And so what we know is that charged particles and magnetic fields are affecting not only the Earth's climate and weather, and it does that because the Earth has a magnetic field around it called the magnetosphere, shown in blue here on this chart. And there's a huge solar wind, this amazing wind of charged particles that comes off of the sun, that's punctuated by these extraordinary kind of storms on the sun, these mass ejections and these solar flares. And this wind comes toward the Earth, and we are protected on the Earth by our magnetic field, the magnetosphere, and it is distorted by the solar wind, which compresses it on its leading edge. And what that does is drive all of that energy, most of that energy, around the magnetosphere, and it comes into the Earth at the poles. It comes in at the North Pole and it comes in at the South Pole. And what it does is it generates the aurora borealis. That's what the northern lights are all about. Is that what you're seeing is all of this energy.
First, the sun's energy absolutely does ebb and flow and has generally increased over the last 70 years, even if only slightly. NASA recently joined this discussion, forcefully asserting that slight solar variability can have drastic changes on the climate. Scientists are observing that this is one of the most influential climate-forcing factors. Daily viewers in our community were set alight as they had heard this before. It's certainly not a new notion, but we are now gaining more of an understanding of how the sun and cosmic rays affect our climate, and we're learning the true power of energy from outer space.
And what you can see is that that energy that's coming to the Earth is also coming to other places. Those changes in energy change the jet stream. And the jet stream, as those of you who are familiar with aviation know, are these huge kind of rivers of high velocity wind that flow across from west to east on the northern hemisphere and from east to west on the southern hemisphere. And they are velocities of upwards to 200 knots. And if you want to really go fast going from the west coast to the east coast, if you can get up in the jet stream, you can go really fast. But what happens is that all of this energy coming off of the sun influences, as it changes with the storms and the other punctuations, as I said, of this energy and the changes in energy, it drives the jet stream different places. And the jet stream drives the climate and the weather on this planet. So there's a direct correlation between what happens on the sun and what happens on the planet, on our planet, in terms of weather. And there are now weather forecasting services that watch what's happening on the sun and can tell you with high degrees of accuracy what's also going to happen in terms of the local weather. There's another thing that's happening, and that is that the Earth's magnetic field is decreasing. And it's decreasing, and it's accelerating, and it's decreasing.
Keeping in mind the move towards space weather influence of the climate, the piece of the puzzle that gets almost no mention in the press is the one I consider most important. Earth's protective interface with energy from space, known as the magnetosphere. This is the visualization of it weakening over the last 400 years. Considering that this is well known in the scientific community, it's curious that we do not hear more about it, even as NASA finds it doing its Swiss cheese impression.
The Earth's magnetic field is morphing, and it's changing from where the north magnetic pole is toward the northern part of the planet, and the south is at the southern end, and it's working its way through gyrations to where it's going to flip, and you're going to get a magnetic pole shift. And that has significant implications, apparently, on terms of the weather and the climate on the planet. And there's these combinations of things, so that when you have a decreasing magnetosphere, you have a decreasing magnetic field on the Earth. What it allows is more of the energy to come in from the sun. And so again, the sun is driving all of this in combination with changes that are going on the Earth. What happens at the same time is that you get Earth changes, because as more energy comes from the sun to the Earth, it turns into things like earthquakes and volcanoes that get kicked off. And there's a direct correlation between coronal holes on the sun as the sun comes around. And there are these kind of places called holes where the magnetic field doesn't hold in the energy that otherwise would come off. And so you get these streaming of rivers of energy that are concentrated. And when those streaming rivers of energy, and they come out of places like this green place on this chart and on the blue place, when that energy comes and it hits the Earth, what it does is drive itself down into the Earth, and it influences, and there's a direct correlation with the number of earthquakes. And so all of this ties together in a big system. And the problem is, right now, is that the sunspot activity is decreasing, and the whole activity of the sun is decreasing. And what that is doing is influencing the whole system. And so what you're starting to see now is that increasing numbers of scientists are coming to the question, starting to question and say, Are we on the edge of an ice age, a mini ice age? Has the Earth reached a sharp climactic shift? Is it reaching another tipping point? More and more scientists are now coming on board. Even NASA is starting, and NOAA are starting to raise questions about whether, in fact, we're approaching a period. And like these Russian scientists here say, the Earth may be headed toward a mini ice age within a decade.
Folks, there is no doubt about it. The planet is warming up. However, if one has access to all the information, one could objectively reason that climate extremes is a more appropriate moniker than global warming. The examples are so numerous, and it's not just temperatures, but severe weather, flooding, drought. And amidst trend and propaganda, there remains a significant possibility that a solar shutdown could swing us into an ice age within a few years. I was initially drawn to this topic while investigating Earth changes for which humans deserve no blame. Earth's upper atmosphere is shrinking, more so than for which NASA can account. If you find some of the many other outlet articles that picked up the story, you're likely to find that scientists were expecting some collapse at solar minimum due to a lack of flares that expand the atmosphere, but they weren't expecting this much. So close to the answer. Lack of flaring collapses the atmosphere. Well, as solar maximum ended in the early 2000s, our solar minimum began normally only to encounter turbulence in 2007, when the coronal holes left their normal polar positions. The solar minimum then embraced her name and dove for the floor, setting low records, and by the time solar maximum should have gotten started, we had gone lower. And as the sunspots slowly began to return, they failed to really get a grip on the sun until March 2011. But look above at how high we had gone the last solar maximum, again in the early 2000s. The red line here is very, very low expert predictions for this current maximum, and actual counts have been even lower. Veteran observers know there is icing on this cake, as the sunspots have not been flaring based on their magnetic potential, but instead decaying when facing the Earth for well over a year now. In 2009, scientists began reacting to the significant solar minimum by offering the topic of a mini ice age up for debate, even if they poo-pooed the idea for the most part. Fast forward through the pathetic solar maximum we've seen so far, many more scientists are now beginning to discuss how the sun could affect our climate. Looking back to the Great Maunder Minimum, we see that part of the time frame of Earth's last mini ice age fits this significant time period. NASA and others have now reinforced the concern about a significant solar shutdown. This book, written by the scientists for whom that Great Maunder Minimum was named, seems to indicate that our observations of Earth-facing sunspot decay are not a new phenomenon. In fact, they had a pretty good correlation to a past solar shutdown. And now, we have this, out of Akron and Duke University. We've waited for a report on the outer planetary effect on the sun, and this one suggests multiple secular variations and predicts a prolonged solar minimum centered around 2030. In other words, it would need to start soon. But then again, it already has, hasn't it? There's not a heliophysicist on the planet who doesn't know that the sun's magnetic field is weakening, and prominent scientists at the NSO have predicted that our next cycle may see a sun unable to produce sunspots.
So we're at the quietest sun since the Dalton minimum. The sun is quieter now at this solar maximum. It's quieter than it's been for the last 190 years. And 190 years ago is when it was cold at that period of time. And so now what you're seeing across the planet is record cold. Now it's not just record cold because it's hot at the same time, record warmth. And so what is better characterization, as Ben Davidson has said, is that what you're getting here is vacillation. You're getting this ambivalence in the whole system. And I would argue that you're seeing the early oscillations before you get a state change. In complex systems, that's how they operate, is that they don't just go change. What you start to do as the new energy comes into it, you start to get oscillations, and then it changes. And so you're seeing is extremes in warmth and extremes in cold. But the problem is the press only reports mostly on the extremes in warmth, but except for this year, of course, where they're starting to see the extremes in cold. But if you look at what literally is happening is that you've got a record return of Arctic ice. You've got more ice than you've ever had. You've got more ice in the Antarctic than you've ever had before. You've got, like this chart in from July to August of this last year in 2013, there were almost 2,900 record cold temperatures versus 667 warm temperatures. Well, there are other places in the world where it was really warm. And so the point is that it's not just really getting cold, it's getting warm and cold, and these things are all over the place. This year, 2014, this winter that we're talking about, that we're living in right now, the Farmer's Almanac said it's going to be a bitterly cold winter. And but still, in the face of all of that, you get this kind of reporting from the press. You get the press saying, as USA Today says here, that 2012 was the warmest year in U.S. history. And you say to yourself, well, where in the world did they get that information? Where does that come from? Well, if you dig into the article, you see that there's one word that gives the whole thing away. If you get into the second paragraph there and you see that they say that the continental U.S. is what they're talking about. Well, why would they just talk about the continental U.S. and not Alaska and Hawaii? Well, the reason is kind of obvious. Is because there was the coldest winter ever in Alaska last year. They're in an ice age. It's the worst winter that they've ever had in terms of snow. At the same time, you're also getting Florida, the coldest winter in Florida's history, and China's coldest winter in decades, and the coldest winter in 100 years is on its way to the planet this year. And at the same time, you find out, of course, that the glaciers are really not melting in the way that everyone said that they were melting. And what you're working your way toward is an increasingly robust science that is starting to say, if we look at the length of the warm periods in the past, as on this chart, you can see that they last about a certain amount of time, about 230 years long. And at the end of 230 years, then it turns cold. And we're just at the end of that period of time. And so there's really good reason to believe we're on the edge of a mini ice age and that it's going to turn cold. Some of the best guesses right now are suggesting that by 2020, within the next 7 years, it will have turned. And my guess is within the next 3 years or so, it'll be clear that it is not getting warmer, that the predominant kind of swings in this whole thing is toward really cold temperatures. So you ask yourself, how might that all work out? Well, if you look at this chart, you can see that there are cool periods and then warm periods, then cool and then warm periods, and we're right at the beginning of what historically would be a cool period, even though the IPCC projects it to be warming. But if it really does get cold, how cold does it get? Well, if it's like the Dalton minimum, it could get really cold in the lower blue line there. Or if it's similar to 1880 to 1915, then it could be kind of moderately cold, and it wouldn't get too cold if it was the chill that we had between 1945 and 1977. So what do we know for sure here? Let's sum this all up. The Earth's temperature has not increased in more than 16 years. We have not had any global warming. And the models that anticipated heating are just not accurate. And historical CO2 peaks have always lagged temperature rises, so CO2 does not drive climate change and temperature change. And there's a much closer correlation between solar changes and climate changes. And predictions about melting glaciers have been erroneous, and there's been an increasing number of temperature extremes, both hot and cold, in the last few years. And so you're certainly seeing climate change, but it is not global warming. One last thing as we leave here. What about the increases in sea level? There's all these horrible, dire predictions about what's going to happen in the sea level. There are things like this that say rising sea levels are a threat to ports, experts say. They say there will be huge sea level rise. Predictions show that by 2100, the water will rise between 55 and 66 inches above its current level. That's what you get scientists saying right now. And there is nothing to support that. There is nothing to support that. And that stuff gets picked up, and you get pictures like this that say that Florida is going to be a good bit of Florida and all of Miami are going to be underwater. And the fact of the matter is, when you look at the amount of sea level rise that is literally measured, look at this chart. Look around this chart. All of those arrows, almost all of them, are these bright green arrows. And when you look down to bright green underneath on the index down below, you can see that what that is 0 to 3 millimeters of increase per year. That's what's happening. That's what's happening right now, between 0 to 3 millimeters of increase per year. Do you know what that is? That's about 1/8 of an inch of sea rise per year. And if you run that out, what you figure out is that it's going to be just a matter of inches over a whole century, if in fact it continues that way at the present trends that is going. And all of these, there is no science that supports the predictions that they say that talk about as much as 200 feet increase of sea level. The huge deceleration of sea level rise over the last 10 years is clearly the opposite of what is being predicted by the models. It's a deceleration. The sea level's reduction is even more pronounced during the last 5 years. In order for the predictions of a 100 centimeter rise, and 100 centimeters is just about 3 feet, in sea level by 2100 to be correct, the sea level rise must be almost 11 millimeters per year for every year for the next 89 years. But since it's dropping, the prediction becomes increasingly unlikely, and especially in view of the facts that one, not once in the past 20 years has the sea level rise of 11 millimeters per year even been achieved, and number two, the average sea level rise of 3 millimeters is only 20% of the sea level needed to rise to predict the 1 meter rise to be predicted. I mean, the numbers are all off. They're all wrong, and it isn't working. So here's the bottom line. This is my last slide. The problem we've got here is that we can be right for the wrong reasons. Those of us who care about this planet and care about the quality of life here and believe that we ought to not be throwing trash into the air and things into the water, and that we ought to be cleaner than we are, and that we ought to get rid of fossil fuels and find better ways, and that there are better ways to do this. We're on the right side of history as far as I'm concerned, but the problem is that so many of my friends have done is they have hung this notion and the argument for cleaning the place up on the whole notion that it is getting warm and humans are causing the climate change. And what's going to happen, and what's almost certain to happen in light of all that we've seen here today, is that we're going to find out very soon that all of these theories and all of this stuff about anthropogenic warming and greenhouse effect and sea level rise and all these things are just not true. What you risk is that the folks who are more concerned about making money, and more concerned about and don't care about the environment, are just going to discount the need to get clean up and find new ways to generate energy and better ways in which for human beings to live on this planet, because we've all hung our hat on the whole notion of anthropogenic global warming. It's not going to happen. It's not happening. Global warming is not happening And what we need to do is find another reason. We've got to find a better reason. And by the way, there are plenty of good ones. There's a lot of money to be made by cleaning the place up, and you can make more money by operating businesses in clean ways than in dirty ways. But we just cannot continue to hang all of this stuff on the notion of global warming. And so what we need to do is start to get a new story. We need to come up with a new argument about why we as human beings need to find better ways in which and cleaner ways in which to live. This is an extraordinary opportunity for us. It's an extraordinary opportunity for business folks to make a whole lot of money, if that's what you're interested in. Do good at the same time. Do well and do good. And that's what we need to do here, because the whole notion of climate change, as we're being told, just turns out not to be true. Thank you very much.